Hi everyone, Francis is here. In today's video, we'll continue from where with the topic partial fraction decomposition. Now the question we have here says the example 3. The question we have here in this example 3 says write a partial fraction decomposition of 3x raised to power 2 plus 4x plus 4x plus 4 over x raised to power 3 plus 4x. Now, the next first step is to look at this expression. What we have at the equation we have at the numerator, and see if it is less than what the highest function, the highest power will have, the highest power of x will have at the numerator. See if it is less than the highest power will have of x will have at the denominator. If it is less, then the function is a rational expression or rational partial fraction, and in this case it is. We have x raised to power 2 here and we have x raised to power 3 here. So the next step will be to factorize the function. Factorize the function we have at the denominator. When we do that, factor this x raised to power 3 plus 4x, we'll have x into brackets x raised to power 2 plus 4x. Now with that, I can replace this with this here. So I'll simply write it as, okay, I'll just write this as x, I'll write this as x into x raised to power 2 close brackets. All right, now take a look at this. One may want to ask, say, oh, this is still a quadratic factor. Let us break it, let us factorize it further. When we factorize, this is an example of, here we'll have one linear and one quadratic. Yes, this type of quadratic equation is a quadratic equation we call irreducible quadratic equation. It is irreducible in the sense that when I solve it further, the x value here would give me a complex number, not a real number. So, but our aim here is to have a real valued x function. A real valued x functions. So this wouldn't give me. We can't reduce this in terms of making x in such. We can't solve this further such that x would have a real can take real number. So with that, I'll call this an irreducible root. The next step will be to look at how do we express this irreducible root. We already know how. Express this in terms of what denominator it's going to take. For the linear function, we already know that when we have a linear function, we write at the denominator here, we express that as x over, we write at the numerator here a constant. We write our constant to be unknown. As you can see in all the previous examples we have done. Now, where the challenge will lie for you or for anyone here, just join us, will be the x plus 4. What type of unknown will it take at the numerator? So since this is irreducible and the x here has a power of 2, the numerator will take a linear function. I will write that as bx plus c. Okay, write that as bx plus c. So it is linear in the sense that this is you can think of this as maybe a line, maybe the slope. This is the variable, this is the constant. So this is how we're going to represent it. Whenever you have an irreducible, I repeat, an irreducible root, you express it as the denominator will be the irreducible and the numerator will be a linear function, such as this. Now the next step will be to multiply both sides with the lowest common multiple, which is multiply both sides by x into bracket x plus 2, x into bracket x raised to power 2 plus 4. Multiply both sides. When I do that, I would have this expression. Do that on this side, I would have a into bracket x raised to power 2 plus 4 plus bx plus c into brackets x. The next step will be to distribute, fold this, distribute a into this quadratic factor here, or into what we have in the bracket here. Distribute x, okay? Distribute x into what we have in the bracket here. And when I do that, we'll have this expression I have on the right hand side here. A raised to power A times x raised to power 2 plus 4a plus b x raised to power 2 plus c. So from here, what we need to do is to, the next step will be to collect terms. We'll have 3x raised to power 2. We equate it with all the terms that has x raised to power 2. And the only the terms that have x raised to power 2 are this, and then b x raised to power 2. So we equate that with this. Having done that, the next step will be to, we'll have a common variable on both sides, and which is x raised to power 2. We cancel that out, and this equation becomes 3 equals to a plus b. 3 equals to a plus b. For reference purpose, we can call this equation 1. Now the next step will be, we'll have 4x here. What term matches to 4x, or what are the variables on the right hand side here that has, or what are the terms that has x? What are the terms on the right hand side here that has x? Well, the only one we can find is when you multiply c times x, we'll have cx. Okay, so we equate cx to 4x, and x is common to both sides. We'll cancel x, and c therefore is equals to 4. Well, it's known. We can call this equation 2, but this is no longer an equation because our c here is known. The next will be to equate 4 with the constant we have on the right hand side here. And what is the constant we have? The constant we have on the right hand side here is what? 4a. So 4 is equal to 4a. It's equal to 4a. Therefore, our a will be equals to 1. With this, we will know our a. We can use our a to find our b. When I substitute our a into equation 1 here, we'll get our b is equal to 2. So with that said, we can go over to express our partial fraction decomposition. As the partial fraction decomposition of this to be, our a is 1 over x plus 2x plus 4 over x raised to power 2 plus 4. So that's it for now. I'll see you in the next one.